Hey, welcome back to how to write a platformer game in Java. In this video and actually the next, we have two parts to this topic, which is resolving platform collisions. And in the first video, we'll just talk about the math behind this and the algorithm, and then in the next video, we'll code up the our program. So let me show you what it will look like once we have this coded up. So we have our platformer here. Gravity's going to pull it down, and then notice that the platform now is colliding with the platform, and we just resolve that collision. I can move left and right. If I go left, then gravity will pull it down again, and it'll catch it again. I can't go to the walls, and same thing on this side. And so if I were to do this again, but make the player be on the right, they'll be on the right side of the screen. It's going to land on the ladder, on the stairs. Notice again, we have a platform collision. And we can't jump yet. There's no jumping right now. We're just having gravity and then resolving the platform collisions. So that's what we want to get to. And this is really the core algorithm for the entire game. So once we get this, then we basically, the rest of the game should be pretty easy. Okay, so let's talk about this algorithm. Okay, so here's some basic physics. I have a sprite here. It has a center X and center Y. And so in our games, velocity is measured in pixels per frame. Every frame, my sprite is going to move a certain number of pixels. And velocity is a vector. It has two components, an X component and a Y component. And for the sprite class that we wrote previously, we have a change X, which is the velocity in the X direction, change Y, velocity in the Y direction. Notice the origin is on top, Y direction points down, as before. So for example, if my velocity is 3 pixels per frame, my change X, my change Y is 4 pixels per frame. Then if I'm at 5,8 pixel location, center of the sprite, then the next frame I'll be at 8,12, because we're adding the 3 to the 8 to the 5 and then 4 to the 8 to get the new position. So basically our new position is basically our old position, add velocity to our old position. So this is the formula that we saw in the video on the sprite class, where we update position by adding the velocity into the position. So old position plus velocity is the new center X position and center Y position. So that's just the basic velocity and position. So what is velocity? Velocity of an object is the rate of change of its position. So here it is again, old position plus velocity is new position, and so there's those two formulas. Now what is acceleration? Acceleration is the rate of change of velocity. So it's the same way. You take the old velocity, you add acceleration, and you get a new velocity. So this is very similar to the previous formula. And so for us, the formula here would be that you take the change X velocity, you add the acceleration in the X direction, then you get the new velocity in the X direction. Same with the change Y, add acceleration in the Y direction, and then you get the new change Y. But for us, the only acceleration happens with gravity, so the only acceleration is in the Y direction, the vertical direction, and this is the gravity. So instead of saying acceleration in the Y, we just can call it gravity, and then there's no acceleration in the X direction. This will be 0. So there's 3 simple formulas here that we need. You add gravity to your change X, the velocity in the Y direction. Then we take the change Y and you add it to the position of the Y. So this is the new position. And then you also add the change X to the old center X. And so we've saw these two formulas already. This is the only new formula. So this is how we do gravity. So that's it. That's the 3 formulas that we need. So let's kind of give you a graphic way to look at this here. So by the way, because the y-axis points down, gravity is pointing down also. So that means gravity is positive, so that it goes the same direction as this. So gravity is positive. And then gravity only affects the vertical component of velocity. If gravity is pulling it down, it's not affecting change X at all. It's only affecting change Y. And that's why we get that formula earlier. In fact, this is the formula. Adding gravity, which is acceleration in the Y direction, to the velocity in the Y direction. So here's an example. Suppose my gravity is 4 and my change Y is negative 12. That means that every frame I move 12 up, 12 pixels up. Right? Again, this is going up, so it's negative. So every frame I move 12 pixels up. Now if gravity was 0, then we would just keep moving up forever, 12 pixels per frame. But gravity is going to change that. So if I add gravity to change Y, I get 8, negative 8. So that means that my velocity in the y direction is slowing down, right? Because we say initially we're jumping up, and gravity is going to pull us down. So we're going to slow down, stop on top, and then come back down again. So in the first frame, it's going to add 4 to -12 to get -8, and then I'm going to move 8. So I'm going to take the change y and then add it to my center y to move up. And then I'm same thing again. The next frame 2, I add gravity again to change y to get -4. And then I'm going to add change y to center y again to move up again. Again, we're assuming here that there's no change x, so we're not moving in the x direction for now. But when we add that in, then it'll be just adding an extra formula. So this is just doing vertical direction, so you understand what gravity does. So again, this is the frame 3. So in this frame, I'm going to add gravity again to change y. So now it's going to be 0. And then when I add change, so that means I got to the peak of my jump, and so this is where I'm not moving, and I want to start to fall down now. So I was down here, I jump up, slow down, stop, and then I'm going to fall down according to gravity again. So at this next frame, change y is 0, so I'm not going to move. And then again, now my gravity is going to add to my change y to get 4. So now I'm going to start falling. I add my change y to center y. I move down 4 pixel. Again, next frame, I add gravity again to change y. So now notice that my velocity in the y direction is going to be increasing downwards because gravity is pulling it down. Next frame is going to be 8. And then I'm going to move down faster, 8 pixels, basically back to where I started out with. So that's basically how gravity works. Okay. Alright, so now that we've done that, let's talk about how to resolve platform collisions. So typically we update our position by adding velocity to our old position, but we don't want to do that altogether. What we want is actually, instead of moving in both directions, change y and change x together, we move in one direction, then resolve collision, then move in the other direction, then resolve collision. So instead of moving in both directions, we're going to do, first we're going to move in the y direction, check for any collision that we have, resolve the collision, and then we move in the x direction, then check for a collision, and then resolve that. So we do one direction at a time, so that way it's easier for us to keep track of any collision and resolve it appropriately. So let's see how this is going to work. Okay, here we go. So again, alright, this is the 3 formula that we need, but we're going to just insert some collision between them. So first thing is we have to change y by adding gravity to it. Then we're going to move in the vertical direction. So this is the vertical direction right here. Change y, add it to center y. And then we're going to resolve collisions. So we have to talk about the code for that. Then we're going to move in the horizontal direction, which is adding the change x to center x. And then we're going to resolve collision again. So the reason why this is a little bit easier is because when I move in one direction, I know what I did and I can resolve collision easier because I know what happened. Then when I move in another direction, I resolve it again because I know what just recently happened. So it makes it easier to break it down to two small steps. Okay, so let's see how this works. Say so we'll just move in the vertical direction first. So suppose I'm jumping, I jump up. And now I'm going to resolve collision by computing the list of all the platforms that collide with the player. You remember in the last video we have a method, check for collision list, that look at the sprite and all the platforms, all these tiles, and see which platform collide with the player. So in this case it'd be these 2 platforms here. So we compute that list. If this list is not empty, that means we collide with something. And there's 2 cases. Now suppose we're moving up, so this is the moving up case. Then we basically set the so we're moving up. Let me go back again. If we're moving up, then we're going to change the sprite so that the top of the sprite equal to the bottom of the platform, so that it doesn't go through it. So that's what this does. Set the top of the player equal to the bottom of the collided platform. These platforms are all in the same level, so we pick one of them, the first one, and then make the top of the sprite equal to the bottom of the first platform. Now if we're moving down, it's the same thing, except now that, so again, I move down and I collide with a bunch of platform. Now I want to set the bottom of the sprite to equal to the top of one of the platform, so that way we fix the collision. So that's why we have those set top, set bottom, get top, get bottom, access mutators method. And then we also need to set the change y to 0, because we can't go through the platform, so we're going to set the y velocity back to 0. Okay, and then we move in the horizontal direction. So if I move right and I collide with I find all the things that I collide with. If I move in right, I'm going to set the right side of the sprite to equal to the left side of one of the platform that I collide with. That way I fix that collision. Then if I'm moving left, same thing. I move left, I set the left side of the sprite to equal to the right side of the platform to fix that collision. But that's it. That's really just the basic logic for doing, this is really the central algorithm for the entire game. So yeah, so we're gonna code this up in the next video. Okay, thanks for watching.